Welcome everyone, and thank you for joining us. I'm Brenda Jettinger from BioPack, and I will be your moderator on today's webinar. And today we're going to be talking about effort and motivation using a hand dynamometer in the MRI and in the lab. We do have a very full presentation, so I'm going to run through these housekeeping items real quick here. Please submit your questions and comments through the GoToWebinar control panel. That's how you communicate with me, your moderator. Also, I'll pass as many questions as I can to the presenters. When the webcam's turned on, if it looks small to you, you can grab this little gray bar here and resize it. Once today's webinar is being recorded, once the recording is done being processed, we'll send a link out most likely tomorrow. Finally, we will have a survey at the end of the webinar. Please complete it so we have your feedback and ideas. Also, I have Caroline Sim on the background. She's going to be helping us address questions. Hopefully we'll not have any technical issues, but please let us know if you are having any issues and we'll help you through it. All right, before we get on to our presenters, I have an announcement. Our 4T Phys Human Physiology Conference, also known as the 4T Phys Training, used to be called T4, but we've renamed it. Conference registration is open. This is an in-person event here in California on July 19th this summer. We'll host 3 days of workshops on physiology, data recording, and analysis. I just want to show you the agenda real quick because we have a really amazing agenda. We have a full fundamentals track where you can, we're organizing people in small groups so you can do hands-on learning for all the major signals. We have a new virtual reality track, and we have like over 28 other skill sessions. So we'd love to see you here in person in July. Our staff will be there. Alex, our speaker today, will be there. And we'd love to see you in person. It's going to be a great conference, training conference. All right, now on to our presenter. We have the wonderful Alex Dimov. He is a BioPack product expert and has taught over 125 workshops on the topic of physiological data acquisition and analysis for the last 15 years at BioPack. Welcome, Alex.
Welcome, everyone.
Alex is a great presenter. You guys are in for a treat. So, Alex, I'm going to go ahead and make you presenter. Here you go.
All right. Thank you. Okay. Well, thank you all for joining. And this is a very, very specialized sort of webinar. Let me just do something here on my end so I can get my camera minimized so I can see a little bit better. Okay, all right. Well, I want to begin by just saying a few words about BioPack in case you're not familiar. We make equipment for measuring physiological signals in pretty much every environment. So it can be wireless, wired, in the MRI, in the field, in the lab. And over 99% of the top institutions in the world run BioPack. And we like to keep track of current publications. If you just do a search on Google Scholar. So currently we have over 48,500 citations using BioPack equipment. Now, let's progress to today's topic, which is how to use clench force to quantify effort for studies for effort and motivation. I took the liberty of generating some AI images to make this a little bit more fun. So these are actually, I just created them this morning for some context. And I'll give you the agenda here. We're not going to spend more than a minute or two, but I want to have present everyone with an idea of what we're going to cover. So we'll discuss typical protocols. We'll go over equipment choices and how to set up equipment. Then how to perform the calibration for maximum voluntary contraction, which is required by every protocol. And then I'll do a couple of demonstrations for different kinds of use cases, fully interactive experiment and a less interactive experiment. So 2 different kinds of designs. And then I'll talk about making the most of the capabilities already existing in our software to aid these kinds of study designs. We'll discuss the external synchronization options, and then I'll cover a few additional paradigms. And finally, there will be a discussion for other technologies that can help in the topics of effort and motivation, like adding FNIRS, cardiac measures, and other ways of measuring effort or providing rewards. So let's go through this list. We have a lot of things to cover. Now, I'll begin with what are the most common protocols, and there really are quite a lot of different protocols out there. But if you look at the literature, probably the majority of the designs are something like that. You have an effort level that's going to be required of the participant to obtain or have some probability of obtaining a varying number of or varying amount of rewards. And also the types of rewards may vary, as well as the quantity. So as you can see here on the picture on the right side, we have a hand dynamometer. You got to clench the hand dynamometer, and then the yellow bar represents the threshold you got to shoot for. And then if you achieve that, you win some reward. So the experimenters vary these parameters. Another design that comes up is using as an indicator of effort the length of time for which the participant can maintain 50% maximum voluntary contraction. Now, all of the protocols, whatever they require first a calibration for maximum voluntary contraction. So we'll cover that as soon as we begin with the software. But I just want to also give you a bit of a teaser about one of the experiment designs we're going to dig into. So I'll just play this for you. Okay, and I won't even explain much here because we'll go quite in depth with this particular example. But just briefly, what we're doing here is the participant on the left side can see the stimuli, can also see an indicator of their effort. And on the right side, we have the acknowledge software where we're recording the actual effort and we're recording markers indicating the current condition in the experiment. So I'm giving you this sort of combined view, and then I'll explain later how this is created. I'll show how it works, how the data analysis works. So yeah. All right, well, let's discuss equipment choices. Now, in this diagram full of arrows going left and right, I will try to present it clearly. We have two main data acquisition systems that are used for these kinds of experiments. There's the MP36R, and in some cases, the regular MP36, the student lab, depending on what researchers have. That's a 4-channel device, and it can interface to two different kinds of hand dynamometers. So it's this one here, and the one that's being held in the hand, and then the other one is a pressure bulb. It's a different design. So fundamentally, there are two different designs of hand dynamometers that we have. You have the typical hand dynamometer, and then you have the pressure bulb. So different kinds of measurements, and it's non-trivial to discuss which one is ideal for your experiment. So if you're at that point, I really recommend afterwards just connecting with one of the your BioPack representative to discuss which one is best. But these are the options. And then with the MP160 system, via the DA100C amplifier, that's the general purpose amplifier, we can connect either to the bulb, the pressure bulb, or to this force transducer, slightly different design than this one. And we can also perform wireless measurements. So using the bioinomatics module, we can connect to, again, the bulb device and EMG at the same time. So a lot of different options, but also I think a lot of you probably already have BioPack equipment. So depending on what you have, you may be looking at adding the sensor that works with your equipment. And then we have the MRI choices. There's only two choices there. Again, we have the two kinds of sensors. Either we have the hand dynamometer or the pressure probe. If we're doing the pressure probe, it's a much simpler installation, just tubing that goes through the waveguide. And we have a pressure sensor that's attached to the DA100C and then a line that goes out to the pressure probe. And if we're using the hand dynamometer, then we go through the patch panel, we have a filter installed, and then cabling all the way to the participant. So both can be accommodated in the MRI. Now, I'll show the setup on both the MP36R and on the MP160. I will not play through all the different scenarios because, as you saw, we have different sensors, different possibilities. I'll just set up this sensor, the clench for the hand dynamometer. I'll set it up on the MP36R, and then I'm going to set up the bulb on the MP160. And we'll perform also for each of those then the maximum voluntary contraction protocols. And they go like that. The participants usually ask to squeeze as hard as possible. The researcher records the maximum value. Then they ask the participant to try to go above this max value. And they basically repeat this 3 times in case the participant is able to go higher and higher yet. Now, let's open up the Acknowledge software here. So I have both the MP36 and the MP160 talking to the Acknowledge software. We can connect multiple devices on the same platform. In fact, you can see here eye tracking devices connected as well, etc. Now, here we have the MP160, and we'll go ahead and open up a graph template here called MP36 experiment graph template. Okay. In fact, I'll open an even simpler one. This has a little bit too many components for the beginning, so let's just open up this one. Okay. And now let's see how was this created. When you're setting up something in the MP36, you go to Setup Data Acquisition. And as you can see, you have a lot of different sensors that you can choose from. So we're using currently the SS25 AOA just because that's the one I have, but the LB is the current choice. That's the newer one. Okay. And we also set the sample rate. I chose, in this case, right here, 100 Hertz for the sample rate, simply because we don't need it to be any faster than that. All right, so we make this selection, and then this is important. We go to Setup, and we go to Scaling. And now by default, the device is going to go for its own values, but we're going to modify them based on the MVC protocol. So these are some modifications I've already done, but let's just start from scratch. So we'll undo everything that's been done. So we'll change this to something else like default. And we come in here. And now we have it like this. So if we go to Setup, Scaling, we see now it's just going to do scaling in kilograms. Okay. Now let's just begin recording. And as you can see, there's a line here that's down at the bottom. I can squeeze and I can let go, but immediately you can notice that we have an offset. Okay, so we have an offset on this particular hand dynamometer. We're not at 0. And I've chosen this one in particular because it has this offset, so I can show you, you can deal with the offset. You can deal with the offset in a number of ways, but let's just come over here and go to setup, and then scaling. And then I'm just going to click here for the 0, and it's going to take a reading of the current voltage that's produced by the hand dynamometer. So when I am applying 0 force, this is the voltage. This is the voltage that it produces. Okay. So we know we have some sort of an offset here. So we can actually add that number like that to the maximum of the scale. So now it's properly taking into account the offset. So that's good. Now let's come in here again and try again. So we'll replace the previous recording. We are right at 0 now. And I'll grab the hand dynamometer and I'll go once as hard as I can, and I'll stop. And what you can do here at the same time is the researcher can look at the maximum and say, okay, it's 18.148 kilograms. So you gotta do better than that. And we can enable on the right side textual value display so the person can see what they're doing. So now we'll do it again. Okay, and let's take a measurement. 18.183 kilograms. I'm going to do this one more time. Okay. So I did a little bit better. All right. Well, let's just stop now. And just to be really, really sure what was the maximum, we can highlight everything. Look at the max. So it's 18 points. Let's round it up as 18.4 kilograms is the maximum. So now the question is, how do we express the scale in percentage of maximum force, not in kilograms? So we just come over here to the same window, setup, scaling. Okay, so now we had 18.4 kilograms. So we're just gonna take 18.4 okay, so yeah, 100 divided by 18.4. So we have a factor of 5.43. So we just put like 543 over here percent. Okay. And let's just fire it up again. Okay, so now you can see that we have the scale in percent, and I can make it a bit more suitable to the type of experiment. So I can say, let's have a midpoint of 50 and 25% per division. And I can also change the unit to percentage. So now if I squeeze, see, I can almost get to 100%. So you can see that it's like basically quite accurate. So that's basically the MVC calibration. Now, when we record data for the participant, it's going to give us the correct scale from 0 to 100%. Okay, and what we can do is we can go and file, save as, and save this as a graph template. So maybe the participant is number 37 or something, and then you save this as a graph template called participant 37. So when this participant now begins the test, even the next time, you can use the same. All right, so that's how you would do this with the MP36, and then it's very similar with the MP160. So now I'll connect to the MP160 device. I have one connected here to my computer. Okay, and then I'll make a new graph window with the MP160. And for the analog channel, I'll just view it by channels, and I'll just enable channel 1. So because we don't really care about the actual kilograms of force, newtons of force, pressure exerted, we want percentage of MVC. So we could just as well work with volts. So we're just going to record the voltage of the sensor that's on channel 1. And on channel 1, I have connected this pressure bulb connected to the DA100C amplifier, but the software doesn't need to know that. All we need to do is this, and we'll call it clench force. And yeah, if I want to change the sample rate again, I can. I wouldn't do that for if you were recording physiological signals as well, like electrocardiogram or respiration, etc. But if it's just this, you're fine with 100 Hertz. Okay, and then let's just record some data. So we're going to record some data. We'll do a series of 3 maximum contractions again. Okay. Okay, and so we have the 3 of them here. And let's just stop. Okay. Again, we'll just take the maximum. So this time it's in volts, 6.386 volts. If we had an offset, we would remove the offset like we did for the other one. We'll just assume we have no offset here. So come back, and this is even simpler than the other one. We go to the setup, and we're gonna say, well, 0 is 0, and 6.386 volts, well, that's 100%. Great. So now we begin the recording, but we have the scale in percentage. If the scale doesn't update immediately, then you can just manually come over here and you can just type in percentage. And then again, we'll set it up like this, 50 in the middle, 25% per division, start. So here we are exerting different levels of force, and now it's on a scale. All right. Let's take our first break for a poll.
All right, great. Thank you, Alex. I'll go ahead and launch this first poll. And I want to remind everyone who missed it in the beginning that you can ask questions through the control panel. I do see your question, Markowski. I just need to, that's a longer answer, so I'm going to save that one to the end. So go ahead and answer the poll and let us know how you're planning to use this technology. Looks like fMRI is a clear winner here. So we will be at the ISMRM conference. I don't know who all is going to be there, but we will have a booth there. So if you're there, please come by and say hello to Benit. He will be our representative at the ISMRM conference this summer. And all right, I'm going to go ahead and close the poll, Alex. It looks like, yeah, clear leader fMRI. Eye tracking is second, FNIR is a close third, and virtual reality is the last one. But thanks all for participating. Back to you, Alex.
All right, thank you. All right, so let's see, my screen's visible. Good, perfect. Okay, so the next thing I will do is I'll do a live demo of and an explanation of the experiment design that I showed at the very beginning. But just a few words first and some pictures as aids. The protocol that I will show, it's created with the Wizard software, which we also use in our virtual reality systems, but it's actually completely perfect for these kinds of experiments. It's Python based, so it's very easy to work with. And the code that I have written today, like if you decide to you want to use that, we'll just provide it to you. All right. So the design is as follows. The participant sees on screen different kinds of stimuli. So it could be money, fruits, or cookies. The number, it's varied from trial to trial. So you can get 1 cookie or 3 cookies, 1 coin or 3 coins. And then you have to exert effort to basically win it. And you can exert either 33% or 66% of effort, and that's indicated by a gray sphere on screen. And whatever you're actually doing with the hand dynamometer at the moment, that's the red sphere. So if you clench hard, your red sphere grows. So this way you get feedback about whether you've managed to reach the necessary effort level. And at the same time, markers are sent to the acknowledge software indicating the type of trial and whether the person reached the effort level required. And you gotta exceed the effort for at least 1 second. Okay, so you can't just like briefly reach 33%. You gotta stay above it for 1 second. So let's jump into the task. So I'll just fire it up here. So here we have the software. Acknowledge is gonna be waiting over here. And we just start up acknowledge remotely from here. So here we have okay, so here now the protocol begins, and we can see I can go above, and then I'll make it so you can see what I'm doing here. So here I'm squeezing, and I'm squeezing harder, but I didn't make it in time, so all the trials are timed. So now I go 1 second above the threshold and I win. So I gotta go a bit harder now to win these 2 cookies. And again, I gotta exert the amount of effort for 1 second to win it. The communication is happening over the network. In this particular case, it's all happening on the same computer, right? So it can also happen on the same machine. And you can have 2 different screens, like the participant may be seeing just this screen with the stimuli, and then the researcher sees the screen with the data, with the hand dynamometer data, and it could have physiological signals as well. All right, and also I think that's probably enough stimuli. So let's just stop the experiment. Okay, and let's just have a look at what was sent here to the acknowledge software. So I'll make the screen big here. Each and every time a new stimulus was presented, a marker was sent to acknowledge. So here it says 33, that's the effort level. The condition is money, and then 2 is the index of the stimulus. So actually 2 means 3 coins were shown because you start from 0. Okay, so here we have sweets, money, fruits, etc. And then here we have the response, and then you only get this marker to be sent over to the acknowledge software if the criteria were met. So if the participant held the hand dynamometer over the threshold for at least 1 second. Now, what's very nice, in the event palette in acknowledge, we can also see a summary of all the events that were sent. So we can see here this very nice summary, and you can also see it populate in real time, but I didn't want to have more things on the screen. You could also, during the experiment, record video. So you can record a video of the participant. You can record also a video of the participant's hand. That's actually very important because depending on, like, if you're clenching the hand dynamometer always in the middle, as you're supposed to, everything would be great. But maybe the participant decided to do something like this, and it's clenching it not in the middle, but some weird position, and that will change the recorded effort. It's actually going to be harder for them to reach their maximum voluntary contraction. So in parallel to instructing them, you can also film them. Now, because we have these markers here, we can perform automated measurements on the data. So we can begin from here and say, let's go to the find cycle, and we'll look for events. And specifically, we'll look at stimulus delivery events that contained the word money. Okay, stimulus delivery contain the word money, and then we can select the first 7 seconds after stimulus presentation, for example, or 6 seconds, or whatever you decide. So now what we can do is we can have the software perform measurements that are over the course of the interval for all the stimuli. So we can go to output here, and we can save the measurements into an Excel spreadsheet file. I'll run this now, but I haven't really defined the measurements. I just have whatever is stock and acknowledged. So I'll run it starting from the beginning. It's going to give me some measurements here. But maybe a very relevant measurement for you would be simply to have a single row here and just look at the maximum. Okay, so just look at the maximum and run the same thing again from the beginning. Okay, so now we have, for all the money stimuli, we have the maximum. But we can be more specific because we have the labels. We can look at the effects of effort size versus reward, etc. And Acknowledge has this really nice new tool called Workflow, where all these things you do manually, you can automate in a single go. It's beyond today's webinar to go into that. We have a separate webinar on Workflow, but it's something you can do. Now, let me jump back here into the presentation just to give an overview of the various parameters, and there's more than that we controlled. So we controlled the number of trials, duration of each trials, for how many seconds you have to hold the hand dynamometer, and we set the types of stimuli and the effort involved. So let's just see how it's done here in the software. So we have a bunch of global parameters, number of trials, effort levels as a function of maximum voluntary contraction, the categories of stimuli, and then the count of stimuli, trial duration, sample rate for the file, etc. So then during the experiment, we generate new trials where we randomly select these parameters, and we can change the way we select these parameters. And when that happens, we just send the condition that was generated to Acknowledge. This whole program is just over 100 lines, and a lot of them are actually default code that you need to just make the communication happen. So it's really not difficult to create this kind of experiment. Now, this is what happens when we are receiving data from Acknowledge. Acknowledge, our software is like a data server that streams data. So then we can receive data in real time, in this case, the hand dynamometer data. So here we can see, for example, we have an object called the force sphere, and we're changing the scale of it depending on the data that are coming in. And also, if the person goes beyond the threshold for a certain amount of time, H, which was in the beginning, then we make the screen go green, and then we also send a marker. So if any of you want to know how this is written, I will not spend more time here, but the code, you can request it. Just reach out to us. We'll send it to you. Maybe we'll just put it as a download. when the webinar materials get published later on. Now, to make this work in the acknowledged software, got to make sure that you have enabled, so under preferences, like you can reach preferences from here, the networking feature. So when you enable the network data transfer, then acknowledge becomes a server that's streaming data. So you can use that by other applications for experiments that involve feedback. Okay, I think this is a good point now to stop for another poll, and we'll look at a different design.
All right, here we go. Our second poll of the day. Do you need help creating an interactive experiment? Okay, so Kenneth asked a question, Alex, how would you have a participant match a force instead of percentage of MBC?
So if it's a specific force, that's even easier, right? Because initially all the transducers, they come with the calibration profiles for kilograms or newtons, etc. So you don't even have to check against their individual performance. If you just essentially use the transducer and account for this offset in the beginning, as I showed you, in case it has an offset, if it's giving you 23 kilograms of force, well, it's 23 kilograms of force. I think that's what the question is asking. But
okay.
Yeah, basically the transducers give you absolute numbers, right?
Okay, he said that was correct, and thank you for answering the question. I'm going to go ahead and close the poll. Lots of people do need help. About 2/3 of people do say they need help. So we'll feel free to reach out to us, and we can connect you with some information. And we'll probably have our reps follow up with you just to check in anyway. So back to you, Alex.
Okay, thanks, Brenda. Now, that's one of the reasons why I wanted to share with you that there are tools that make it a bit easier. But sometimes you can create a lot more right within Acknowledge than you may suspect. So within the Acknowledge software, there's newer features that can make for somewhat interactive designs. So this is called the BioPack stimulus presentation. And I'm going to create an experiment now using BioPack stimulus presentation, where we'll be applying a clench force after an image is seen on the screen. And basically the participant has to use the clench force to demonstrate how much they want to win whatever is on the screen. And for example, candy, fruit, and the higher percentage of winning comes with higher effort. Now we can either provide feedback or not provide feedback, but I will provide feedback in two different ways, via audio and also with a gauge that moves. So I'll show how that works. To make this simple, I just have a few images that will be used for the presentation. So let's go back into Acknowledge now, and we'll set up a new stimulus presentation. Now, this is the BioPack stimulus presentation interface. We'll put some images in here. So we have 2 images of fruits, 2 images of candy. For each of these images, you can control for how long they'll be presented and a bunch of other parameters. We can also have different categories, so we can make them be a different category. For example, the category of candies or fruits. So then you can have randomly produced images from different categories. Again, we're not going to go in depth. I just want to show you how it works, and then if you have if you find that it works for you, or you could do something like that, then just contact us to see how your experiment can be done. But I'll just make it very simple now, and I'll just change the category here to all of these to be yeah, it's already none, so that's fine. And I'll make another stimulus here called random. and it's going to take stimuli from the none category. So that's for all of them. I'm not going to waste the time now to create separate categories for candy and fruits. So we'll go now here to sequence. We'll put a random and we'll have it repeat maybe 4 times. Okay, so what will happen now is you will get 4 images and they will be randomly selected, and currently they'll be random with repetitions. So the next thing we want to do is go to data recording. And if we have an eye tracker connected, we could also look at the eye tracking data, but we don't have an eye tracker connected right now. And we'll use a graph template that I've already created for this. So it's this one here. Let's open it up. Okay, so all good here. And let's just run the experiment. So we'll come over here and hit record. So yeah, let's save it, and we'll call this webinar presentation. Save it. And now just watch what happens. This gauge, and I can place it somewhere here, is indicating the amount of force, but also it's giving me sound. And I don't know if you can hear it, the sound level changes. For this and for this level of effort, we have different sounds. Okay, so you could, for example, indicate on the picture itself with maybe a yellow or a red rectangle what level of force the participant should be shooting for if you want to make a design like that. Now, again, within the software, all the data is here and the markers are here, and they say candy, fruits, and candy. Okay, so we can perform the very same analysis as before. So when we went to find cycle, we could look for all the candy. This time, we can just look for all the candy, and so if it contains candy, then we do selection, and then we choose what to select. So we could perform the same kind of setup. So let me just change it to candy. Okay, so here are the 2 instances of candy, right? And then you can perform the measurements. So this is very convenient. A lot more can be done, and you're probably wondering, how do we make that gauge appear, and how do we make the sound work? So I'm going to cover in detail how these things happened. So basically, what I want to show you is the following. These are various biofeedback options within Acknowledge. So we can see the input values of the signal. We can see a gauge. We can have a display of the value on the waveform. We can have target lines that are overlaid on the recording. We can have an audio as a feedback, which I just demonstrated. And we can also have separate views for the technician and the participant, meaning that whatever I was doing now on a single monitor, you can have over 2 or 3 monitors. And within Acknowledge, you can have different data views. What I mean by this is you go here and you have a different data view. So now we have 2 different data views. So you can see here, this is one data view, this is another. They could go on separate monitors. You could choose, for example, the force display to be on one monitor or another. There's so many ways to customize the interface, so we'll go over that as well. Let's take another poll and then we'll jump into that.
All right, here I am. Okay, I'm launching the poll. And I know, Markowski, you asked a question, so we'll get to that in a little bit. Let's see, Frank is there. Okay, so Frank just asked a question. Is there a way to move an image like an apple or cookie up or down in the visual display by squeezing?
Yeah, for that sort of interaction, you need to use, you cannot do it in Acknowledge right now. So that's not possible. Okay, so that's why that would be, that kind of design would be better for the first thing I showed.
Okay.
Yeah, but you can move that gauge like left and right, right? You can move an apple up and down with the other software.
All right, it looks like we've got most people, well, almost half people using CyclePy, and then E prime is a close second, and then third of people are other. Feel free to tell us what the other thing is that you're using. You can chat that to us just for fun. All right, I'm going to go ahead and close the poll. Alex, back to you.
All right, thank you. So now let's just make sure that I can show you how to use these tools that help me make this last demonstration. I'll probably just keep my presentation not maximized because it's easier to cycle back and forth. Now the gauge is something that not many people are familiar with that exists in the software. Let me open up that template that I had created. So we just open up template, and yeah, here's the gauge. So how did we make this appear? Let's close it. From the MP36 or MP160 menu, you can go to Show Gauge. By default, if you right click, and you have to right click or nothing will happen, like if you left click, nothing happens. You have to right click and go to Preferences. You can choose the image that's there by default. Now, there's 3 images: pressure, stopwatch, and BPM. So if you look at this, the pressure image. And here we have a stopwatch image. So these are default images already coming with Acknowledge. But I made my own image. So you just browse, go here to the folder for the webinar. And I made another gauge as well with different levels, but here's this one. Okay, so that's how you load the image. But then beyond loading the image, you have to also tell Acknowledge how we're mapping the indicator. So mapping here, we're saying that 100 volts or 100% is equal to going all the way to the end. And that's what we want if we're doing MVC, but you can, of course, change it. So this is very important, the mapping. You have to make sure the mapping is what you want it to be. Then the indicator, you can change the length of the indicator. You can also change the thickness. You can make it white if I want. So now it's a white indicator. And that's how the gauge works. Okay. Now, the next thing I want to show is the current value display. I think I briefly demonstrated in the beginning, but if we just begin a recording here, and I'm just going to squeeze the hand dynamometer. So let's just set it up like this. Okay, click on the right side, choose Show Textual Value Display, and there we have it. I can change the position. I can put in the top left, for example, right here. So the participant can now see what number they're getting to at the moment. Okay, so that's that. We can also overlay different target lines onto the recording. So how do we do that? We can come back here and we'll add a calculation channel. So this calculation channel is going to be just an expression, and it's going to be equal to 30% to 30. Okay, so just put percent, 30%. And then we're going to do another one. another expression, and that one is going to be 70%. Now, this is what happens when we overlay the channels. So let's just close and start again. Okay, so here we have all these channels. We'll click here and make sure everything is on the same scale as the top channel. And we'll put them on the same screen. So I can see now when I'm above 30%, and when I go even higher than that, I'm crossing these lines so the participant can see it very clearly. But these lines are still not so easy to see. So we can make some changes. We can make this color black. We can change the line thickness, and we can do the same for the other ones. So we can have thicker lines, and we of course can change the colors. So now it's much clearer that the black line is crossing the red, and the black line is crossing the blue. Okay. And that's basically if you're doing a protocol of holding at 50% maximum voluntary contraction, that's what you can do, is you can use those lines to instruct the participant to stay above 50%. So you can do one at 50% and just keep it there. For audio feedback, let me explain how that works. It's taking advantage of a capability in Acknowledge, again, for creating expressions on the data. So we'll come back here to the channel setup. And the first channel here, you can see, is also an expression I created ahead of time. It's not going to make much sense to you right now, what I've written here as far as an expression. But what this expression does is it mutes the sound below 33%. It provides an 880 hertz tone between 33 and 66%, and 1200 hertz tone above 66%. It's just an if-else statement. So it's just checking for the current data if it's within certain limits, and then it's telling the software, okay, we are between 33 and 66, output a cosine waveform at 880 hertz, and then otherwise, if we're above 66, output a 1200 hertz cosine waveform, otherwise output 0. So you can create your own by just seeing in the Acknowledge manual how it works, but that's basically the expression you would need for this particular trick to work. So you create the expression, and then after you've created the expression, you have to go to sound feedback. And under sound feedback in Acknowledge, got to make sure it's enabled. You can choose the output sampling rate, depending on the quality you want to have, and then choose the source channel. So that's your expression. So you got to make sure the correct one is set here. Then you can play with these other settings if you want. But that's how I made that work, so that you can have feedback to the participant with just sound and without using any external devices. Now, speaking of external options, I think that's what a lot of you are doing anyway. So let me provide an overview of the many ways in which you can do that. So one option is using control channels in Acknowledge. Control channels are digital channels of the system that will change their state based on the current analog or some other channel. So I'll have to go back in the software again and come back to this menu, and I'll create a different kind of channel, which is called a control channel. Okay, and then the source can be the clench force. Now in the control channel, we can set when when we send out a post, for example. So, when we can send out a post when we're within 33 and 66%, for instance. So, right, like when we're inside that, we can send out a post on the digital lines of the system. And both the MP36 and the MP160 have a way to send and receive digital lines. If you're interested in adding this capability to your system, just connect to your representative. But that's what these control channels do. So this is a simpler form of communication where you turn and off, on and off digital channels based on the current force level of the participant. So they don't really even have to use network data transfer, or you don't even have to use other more complicated ways of achieving it. So if you want a binary control, then you can do that. Then acknowledge will do the math for you. Another option is whatever is recorded in the system can be provided again as analog output by the system, but it sort of defeats the purpose of using the system. However, you can definitely do that. With all the channels we record are also available as amplified analog outputs. So if you have some card connected to your system that's a to D converter, you can feed in the signal. NDT, or network data transfer, is what I've been using in the example with Wizard and Python that streams data over the network. You can also connect to Unity, which is commonly used as a game engine, but also you can use it as 2D experiments. CyclePy, you can interface via NDT as well, because we have examples for Python, so you should be able to adapt those. And we have a hardware API, but I have to say that the hardware API is the most complicated way of using the equipment, because then you don't have access to acknowledge. You write all the code that controls the device, and yes, you have the data straight in your application, but it's something that you do when you have more programming experience, and probably a bit overkill for these kinds of experiments. But I've seen publications using MATLAB as well, or many other custom approaches using hardware API. So it's a valid option. We have one more poll, and then we'll go off to the last, I think, very interesting topics.
All right, here we go. Let's see. I don't have any additional questions right now, other than a couple questions around, exporting to other software. So we'll just save that for the end. And let us know your current solution, how easy it is to use. Looks like it's easy with programming knowledge primarily, and not, so 24% of people are saying not easy. Okay, all right, well, go ahead and close this poll. Back to you, Alex.
Okay, thanks. So I think you will like this part. This is a bit of a different examples and ideas and capabilities. So first, I want to show you another kind of experiment that's again created in the same program. In this particular one, you have to use the hand dynamometer to follow whatever line is displayed on the screen, and you get feedback depending on how well we do. So let's just play it here. So you will see here there's a correct indicator. And I don't know if you can hear, but there is also a change in the volume of a song that plays in the background. So the more accurate you are, the higher the volume of the song becomes. So this is another example of something that I've seen performed. It's a bit of a combination of effort and cognitive effort, because you have to also pay attention to the line that is on the screen. Now, we can do studies with diodes or have multiple hand dynamometers. So you can use 2 hand dynamometers on one person, and there are designs, experimental designs to do that. But it's interesting when you work with dyads, there are multiple people as well, because the choices that they make can affect others. So, for example, some researchers have used electrical shock as an outcome. So imagine if you don't exert enough effort, the other participant gets shocked. So that can lead to some interesting experimental designs. And we have, for example, we have an interface for E prime where you can control the electrical stimulator dynamically. So then with what I showed you before, with the control channels showing whether the person reached the threshold or not, you can, based on whether they reached a certain threshold, you can shock somebody or not. This is a tip that I mentioned previously about recording the hand, because we have this media menu and acknowledge, because somebody can do that and reach maximum voluntary contraction very easily. So you can just point a camera where the hand can be seen. Oh, it's also interesting and to use functional near infrared systems for these effort and motivation studies, and we have 2 different kinds of systems. We have a system that looks at prefrontal cortex, and you can have it mobile or you can have it in lab. And we also have a full head system that even combines EEG, and then you can look at the entire head. So goes through the hair, and you can record from anywhere. Because, for example, parts of the dorsolateral prefrontal cortex appear to have an association with effort and motivation. And then, as far as other ways of measuring effort, breath holding is an interesting one, where your motivation level can affect how long you can hold your breath. So all we need for this is just a respiration belt, and then you can run this type of paradigm. Or you can use a little thermistor placed under the nose of the participant, so the moment they try to inhale, you can see it. Vibromyography, or VMG, provides muscle force in real time. So that's done with the use of tiny sensors that are attached to the muscle. This is very different from EMG. It actually provides a measurement that's very repeatable, and it's linked to the muscle force. So instead of using the hand dynamometer signal itself, you can use the muscle signal. So maybe you want to measure the muscle force, but the actual muscle is not so easy to study, but you can place the vibromyography sensor there, and then you can still perform an experiment quantifying effort. It's interesting also to look at the cardiovascular effects in effort and motivation studies. And there are many ways to do that. You can look at cardiac output, blood pressure, but I want to bring to your attention TREV, which is transradial velocimetry. It's basically like doing bioimpedance on the arm over the radio and the ulnar artery. And we have an application note dedicated on TREV. We're actually thinking of doing a webinar on that, because it's a very interesting topic. So without spending too much time, I'll just mention here the indexes that are relevant to TREV. So you have contractility, acceleration, cardiac output, etc. And specifically in our application note, we detail results of many studies, and one of them is the grip anticipation test, which I think is worth mentioning in the context of today. So with this grip anticipation test, the participants have to deliver periodically a very high level exertion hand grip, and they have to do this every 2 minutes. So what happens is that the contractility index in the 15 seconds just prior to the next grip task is way higher than the contractility index during the rest of the time. So there is some cardiac effects for anticipation. So it would be I think very interesting to combine, of course, as long as you use on different hands, because you don't want to move that hand. So this would only work when using one hand dynamometer, and then the other hand would be outfitted with the tread measurement. Much less invasive than recording full-on cardiac output or blood pressure. I also want to make a case for virtual reality. As some of you may be aware, we also sell complete virtual reality solutions, because in VR we can provide actually immediate rewards for participants. Like, things can happen, interaction with an avatar or an object can become animated because of your effort. Some room can reveal itself, etc. You can come up with interesting designs to provide rewards right then and there. And also the experience of biofeedback can be made to feel more visceral, like the light in the room can change, the sound around you, etc. So there's many things that can be done. So what happens is then you have scenarios that are of a higher ecological validity in VR than in front of a computer. And if you think it's hard, it's actually not so hard. We have webinars about how to create experiments for that, and we can, if you're interested, reach out. Now, the alternate modes of stimulation that we provide, such as we have a scent delivery system, we have electrical stimulators, haptic stimulators that provide haptic stimulation, and thermal stimulation, so you can receive hot and cold stimulation. Now, those can be used in effort and motivation studies as positive or negative, rewards or punishments for the trials, and they can be automated within the acknowledged software again. I just wanted to mention novelty as a reward again in the context of virtual reality. So a lot of things I covered here. I hope it has been interesting and hopefully gave you some ideas. I think we can proceed to Q&A.
Okay, great, thanks. I'm just gonna make myself presenter real quick. If I have to go back to you, I will. Just wanted to tell people who may have missed it in the beginning, our 4T training conference is July 17th through the 19th here in California. If you can make your way out here, you'll get to experience a variety of BioPack equipment, including, I don't know if we have a session specifically on the hand dynamometer, but we certainly can bring it and have it in our support area. So it would be a great opportunity for you all to get some in-person experience with the different equipment that we use, and also all of our staff will be there, including Alex. Just want to show you the agenda real quick. Again, if you were here in the beginning, you can see we have like over 30 sessions where we'll be training our customers on and potential customers on this equipment. So hopefully you can make it out here. And I want to show everybody as well. My screen isn't advancing. 1 second, something weird just happened. Okay, here we go. Back. So a few people asked a question about how to export the data to another software like CyclePy. So I know that question came in through the registration, but also in the live webinar as well, Alex. And let me know if you want me to switch.
Yeah, I think that's where the network data transfer protocol can be used as one way, right? Probably for a CyclePy, the ideal way, because we have examples in Python we can share with you. So then you need to get this network data transfer protocol. It's a licensed feature from BioPack, and just ask us to provide you examples in Python for how to use NDT.
Okay. All right, let me just show you a couple of things on our website here. So Alex mentioned other webinars. We have over 80 webinars, training webinars. Some of them are real basic, like acknowledge fundamentals. Others go into a lot more detail, like virtual reality, like what Alex mentioned. I'll show you those webinars. If you scroll all the way down, you just go to biopack.com/webinars, And then here's all the virtual reality webinars that Alex has presented at. And if you scroll all the way to the bottom of any web page, you'll see our local sales representative. Mine is Amy Walker. But you'll see whoever your representative is. We have representatives all over the world, and I can send an email directly to her. Also, we have a great support team. They're here to help you. So once you have equipment, if you're looking to get it set up properly or have questions about setup, definitely feel free to reach out to our support team. They can also be reached at support@biopack.com. So we did just get another question, a couple questions. Okay, so follow up to the other question related to exporting the data. Can this be done in real time with NDT, network data transfer?
It is in real time, right? That's exactly this. In offline, you can export in many different ways, but NDT enables Acknowledge to become a real-time server that just passes on the data over the network to other applications.
Okay, great. So I'm gonna just, I know we're way over, so I'm just gonna go ahead and wrap things up here. And yes, Milad, if I'm pronouncing your name right, yes, this will be recorded. That's in my closing comments. So yeah, just letting you know, you can watch the on-demand webinars at any time at your convenience. All right, so let me just share with you our closing comments here. And today's webinar was recorded. We'll email you a link as soon as it's done recording. If you'd like the slides, we'll also email those. When you close the webinar window, you'll see a survey. Please complete that so we have your feedback and ideas. And of course, visit biopack.com for additional references, including screenshots on specific features and analysis tools, application notes providing step-by-step instructions, and information on upcoming events and past webinars. As I mentioned, we'll be at ISMRM. We're going to be at APS. We're at all kinds of events this spring and summer. So, of course, our own event, the 4T Fizz Training Conference. So please join us there. Alex, anything else before we conclude?
So yeah, again, as I mentioned during the webinar, the code that I used to create this task we'll share with you. Just ask us if you wanna give it a go. As long as you have a system from us, you'll be able to use it together with the system, and you can just try it.
Okay. Well, thanks everyone. Thanks Alex for preparing all those slides. That was a lot of work and preparing the demo. We appreciate that. All right. Thanks everyone. Have a great rest of your day. Take care.
Thank you. Bye.